Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a right square prism having edge of the base 40 millimeter and axis height has been provided to us as 60 millimeter. Now this right square prism, it is resting onto the horizontal plane onto its base with one of its rectangular faces inclined at an angle of 30 degree with respect to the vertical plane. So if we locate square prism onto horizontal plane into this orientation, so we will find that the two faces of the square prism, they will be parallel to the vertical plane. So this is the incorrect orientation of the square prism with respect to the two reference planes over there. So now we have to manage one of the vertical faces or one of the edges of the base to be inclined at an angle of 30 degree with respect to the vertical plane. So here we have assumed that this edge of the base or this vertical face, that is 14DA. So it should be inclined at an angle of 30 degree with respect to the vertical plane. So this is the correct orientation of the square prism with respect to the two reference planes over here. So here we have got square prism. The bottom face we have labeled as A, B, C, D, whereas the top face we have labeled as 1, 2, 3, 4. So O point, it lies at the top face corresponding to the axis, whereas O1 point of the axis, it lies onto the base of this particular square prism. So now OO1 happens to be the axis of the square prism. So once we obtain the midpoint of the axis, now an auxiliary inclined plane which is inclined at an angle of 30 degree to the horizontal plane and which happens to be perpendicular to the vertical plane, it is going to bisect the axis of this inclined right square prism over here. And now we can check this auxiliary inclined plane. It has intersected with all the vertical edges of this particular square prism. That is the vertical edge 1A, 2B, 3C and 4D. So all the vertical edges of the square prism, they have been intersected by this auxiliary inclined plane. So with this information, we are required to obtain the orthographic projections of this truncated inclined right square prism and the development of the retained surface of the prism over here. So let us begin with the construction of the orthographic projections of this inclined right square prism over here. So now we know that here we have got a right square prism having edge of the base 40 millimeter, axis height 60 millimeters, such that one of its rectangular faces or the edge of the base, it happens to be inclined with respect to the vertical plane at an angle of 30 degree. So here we have drawn a projector line which is inclined at an angle of 30 degree with respect to the vertical plane. Now onto this orientation line which is inclined at an angle of 30 degree with respect to the vertical plane, now we have drawn the top view projections of the square prism over here. So as we are going to look at this prism from the top, we are going to obtain square projections of this prism onto the horizontal plane in the top view projections over here, and these projections will be drawn below the XY reference line. So we know that A, B, C, D, these are the 4 points of the base of the square prism. So these 4 points we have marked appropriately on the inner side of the top view square projections which we have obtained corresponding to this inclined right square prism over here. Similarly, the top face points 1, 2, 3 and 4, they have been appropriately marked on the outer side of the square top view projections over here. And now once we join the diagonals AC and BD corresponding to this inclined square prism, we will be obtaining the access points O and O1 into the top view projections over here. Point O, it is the access point at the top face of the square prism, while point O1 happens to be the access point corresponding to the base of the square prism over here. So now once we have drawn the access point O and O1, now from these access points we can mark the axis into the elevation projection view. And now we know that the height of the axis of the square prism happens to be 60 millimeter. So now once we mark the height of the axis equal to 60 millimeter, so now we can draw projectors from all the 8 points of the base and the top face over here into the elevation projection view. Now the front view projections corresponding to this inclined right square prism we have been able to obtain. So now we can see we have been able to obtain the points A dash, B dash, C dash and D dash into the elevation projection view corresponding to the base of this square prism over here onto the XY reference line. Why? Because the square prism happens to be resting onto its base A, B, C, D onto the horizontal plane. Now at a height of 60 millimeter, now we have been able to obtain the 4 points corresponding to the top face of this square prism over here. So these points, they are 1 dash, 2 dash, 3 dash and 4 dash. And besides this, the 2 access points O dash corresponding to the top surface, O1 dash corresponding to the base of the inclined square prism we have also been able to obtain over here. So now one thing we have to observe over here, the vertical edges 1A, 2B, 3C. So they are all visible to the observer as the observer is going to look at this prism from this side. While the vertical edge 4D, this edge, it lies on the rear face of the solid. So this vertical edge, since it is farthest away from the observer and nearest to the plane, so in the front view projections we are going to obtain hidden line projections or the dotted line projections corresponding to the vertical edge 4 dash D dash over here, whereas all the 3 other edges 1 dash A dash, 2 dash B dash and 3 dash C dash, they will be drawn with the help of object lines into the elevation projection view. So now we have been able to obtain the orthographic projections corresponding to this inclined right square prism which has not been cut by any given cutting plane. So now we have been provided with the information that this inclined right square prism has been cut by an auxiliary inclined plane which happens to be inclined with respect to horizontal plane at an angle of 30 degree, bisecting its axis over here. So we know the axis height, that is O dash and O1 dash. It happens to be equal to 60 millimeter. So the midpoint of the axis will be lying over here. So at a distance of 30 millimeter from the top face. So we have marked a distance of 30 millimeter from the top face, marked a point onto the axis so that we are able to locate the midpoint of the axis into the front view projections over here. And now an auxiliary inclined plane inclined at an angle of 30 degree with respect to the horizontal plane, it is going to pass through the midpoint of the axis over here, so that this portion of the solid, it has been cut by the sectioned plane and this portion will be removed thereafter. This is the remaining portion of the prism which is left behind. So this we will call as, it is the retained surface of the prism. So the retained surface of the prism will be the vertical edge. This portion of the vertical edge 3 dash C dash will be retained. This portion of the vertical edge 2 dash B dash will be retained. This portion of the vertical edge 4 dash D dash, which is lying on the rear side of the solid. So that is why it is drawn with the help of dotted line. and this portion of the vertical edge 1 dash A dash has been retained. So let us evaluate the 4 points of intersection of this auxiliary inclined plane with this inclined right square prism over here. So even in this construction over here, we have discussed that this cutting plane, it is going to intersect with all the vertical edges of this square prism over here. So the point of intersection which is obtained onto the vertical edge 1 dash A dash, this we have labeled as point 11 dash. The second point of intersection 12 dash, it lies onto the vertical edge 2 dash B dash over here at this location. Point 13 dash, it is the point of intersection of the cutting plane with the vertical edge 3 dash C dash over here, and point 14 dash has been obtained onto the vertical edge 4 dash D dash into the front view elevation projection view over here. Now we can see all of these 4 points, because they are obtained onto the vertical edges corresponding to the square prism. So when we are going to look at all these 4 vertical edges from the top, so these points of intersections, they are going to converge with top view projections of the corresponding edge view top view projections over here. That is point 11. It is going to converge with points 1 and A in the top view projections. Similarly, point of intersection 12, it is going to converge with or coincide with the vertical edge projections B and 2 over here. Similarly, the point of intersection number 13, it is going to converge with or coincide with the vertical projectors corresponding to the points 3 and C over here. And point of intersection 14, it has again coincided with the vertical projector edge 4 and D in the top view projections over here. So this way, these 4 points of intersection locations in the front view projections and the top view projections we have been able to appropriately obtain over here. And now if we are going to join these points of intersection in the top view projections, that is 11, 12, 13 and 14. So the sectional top view corresponding to the apparent shape projections corresponding to this cut surface area, we have been able to obtain into the top view projections over here. So the sectional top view projections which we have been able to obtain over here, that is going to represent the apparent shape of the cut section corresponding to the intersection of this auxiliary inclined plane with respect to this inclined right square prism over here. So now let us obtain the development of the truncated square prism using the parallel line development method. So from the top face of the square prism, we have drawn a horizontal line. From the base of the square prism, again we have drawn a horizontal projector line. Now the distance between these two horizontal projector lines will provide us with the true length height of this right square prism over here. So now we are going to open up this square prism from vertical edge 1A over here. So this is the vertical edge 1A. So now we can see that we are going to mark 4 points A, B, C, D and A over here, so that the 4 edges of the square prism we are able to obtain in the lateral surface development view. And this edge length between A and B, B and C, C and D and D and A, this will be equal to the edge length of the base, which is the true length, and it is equal to 40 millimeter. So the distance between the points 1 and 2, 2 and 3, 3 and 4 and 4 and 1, it will be equal to 40 millimeter each. So now we have been able to obtain the development of the uncut right square prism over here, as we are going to open out this prism from the vertical edge 1A over here. So now let us obtain different points of intersection into the developed surface area over here. So we know that point 11 dash, it happens to lie onto the vertical edge 1 dash A dash. So if we draw a horizontal projector line through the point 11 dash, so wherever this horizontal projector line drawn through the point 11 dash, it is going to intersect with the vertical generator 1A. So we are going to locate the location of the point 11 into the developed surface area over here. So point 11 has been located as a starting point. Point 11 will be located over here as the end point of this particular development over here. Next point available with us is point 12 dash over here. So we know that point 12 dash happens to lie onto the vertical generator 2 dash B dash. So now from point 12 dash, if we draw a horizontal projector line, let us evaluate the intersection of this horizontal projector line emerging from 12 dash with the vertical projector, which happens to be 2B over here. So this way, this intersection point will provide us with the location of point 12 in the development surface view over here. Then the next point available with us is point 13 dash. So point 13 dash is available by virtue of the intersection of the cutting plane with the vertical edge 3 dash C dash over here. So now once we draw a horizontal projector line through the point 13 dash, let us evaluate the intersection of this horizontal projector line emerging from point 13 dash with the vertical edge 3C over here into the developed surface view. So this intersection point has provided us with the location of the point 13 in the development surface view over here. And finally, the last point available with us is 14 dash. So 14 dash point is obtained by virtue of intersection of this AIP with the vertical edge 4 dash D dash of the square prism. So now from the point 14 dash into the elevation projection view, if we draw a horizontal projector line, let us evaluate the intersection of this horizontal projector line emerging from point 14 dash with the vertical edge 4D over here. This is the vertical edge 4D. So it is now this horizontal projector will be intersecting with this vertical edge 4D at point number 14. So this way, into the development surface view, all the 4 points of intersection, they have been appropriately located. And once we join different points onto this development surface area corresponding to the retained surface of the prism, now this is the development of the retained surface of the prism which we will be able to obtain over here. So if we are going to carry out the folding at these particular positions, so after we carry out the folding operation, then we are going to obtain this truncated surface of the right square prism which will be available with us. So this is all for today. So I hope that through this discussion you would have understood about the procedure. How do we obtain the development of the retained surface of a square prism which happens to be inclined with respect to the vertical plane at an angle of 30 degrees. And this inclined square prism has been intersected by an auxiliary inclined plane which happens to be inclined with respect to horizontal plane at an angle of 30 degrees, and this AIP passes through the midpoint of the axis of the square prism over here. So we are going to continue with further discussion regarding few more illustrative cases of development of surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.